Hi guys, welcome back to my YouTube channel. This is my second presentation about Clean City, and I'll start with a brief introduction. Clean City is basically an artificial intelligence model that will be helping us to keep our cities clean. This will be done through the model detecting streets that require cleaning and notifies the responsible parties to go and clean these places. And this will be done through notifications, and the model will be doing that part. We go on and talk about the Clean City dataset. The Clean City dataset is going to be obtained from Kaggle.com. This has different kinds of images that have trash in them. And the dataset is what the model uses to learn how to detect that this place is dirty or it is not clean and it requires cleaning. It will do all that through having this dataset. It is what will be used to enable the model to learn. That is what I could say about the dataset. And we see that the dataset has some features that made me choose it. That is to say, the completeness of the dataset. It had various images which will help my model to work well, depending on what time, maybe also the distances. The distances can affect how the decision making. Maybe some images were taken while it's distant, while other images were taken at close range. Then there is uniformity of data. All the images are in HD and have very good resolutions, and the consistency of the data set. We go on and talk about Bayesian theorem. Bayesian theory is the probability of an event based on prior knowledge of the conditions that might be relevant to an event. This, the way I could explain this would be the probability of A given B. The probability that it is wet outside given that it rained. You see that we are having some extra information about a certain event. Maybe the probability that it is dry because it has been shining since morning. You see that we have particular information that somehow describes what happened before. Yes, and below here, the last line here shows how Bayesian theory is written in mathematically. Then we go on and explain how this here will be the posterior probability. This here will be the posterior probability. This one here will be the likelihood. And this one here will be the prior probability. This is the information we had before or originally before we obtained new information. Then we go on and look at naive Bayes. Naive Bayes is simply an algorithm that uses Bayes' theorem together with a strong assumption that the attributes are conditionally independent. Under this naive Bayes, we look at every feature being identified independently. That is to say, if I have a shirt, every feature about this shirt will be considered to be independent. Maybe a shirt must have buttons, a shirt must have a collar. Each feature you see, maybe the collar, the button, there will be different variables that constitute to being a shirt, and they will have their own particular probability for each. We look at Bayesian networks. Bayesian networks is basically about graphical representations of variables, and we see that it is all about conditional independent relationships. And we can see in this illustration that I have here, this is called a node and this is an arc. A node will contain the variable and an arc will be showing the independent relationship between the nodes. These ones here, exercise and dirt, since there is no arc between them, they will be independent from each other. But then they are conditionally independent to weight loss. And we see that weight loss can happen if you look at your diet or if you do exercises. So it's possible that you can do that and you don't have weight loss. That is the entire thing about conditional independent relationships. It's not a must. You can do the exercises and you don't lose your weight. Or you can lose the weight and it's due to something else, maybe diet, but not exercise. Yet they both somehow, somewhere are related to this weight loss. I hope I've explained that well. And here we just look at the differences between the different things, such as Bayesian networks and naive Bayes. And naive Bayes assumes conditional independency, as we have talked in the slides above before this one. While Bayes' theorem, for it looks at all features being independent. That is a major difference that I observed. Then we also have the difference between naive Bayes and Bayesian networks, where we look at, again, naive Bayes assuming conditional independence, while Bayes networks uses a graphical representation and allows the user to specify the attributes which are independent and those that are not. Then we can talk about, here are just my references, the things that I read from to get some of my information, so you could check them out for more information. Thank you for coming today. Goodbye. Have a nice time.